Today we're going to be talking about the volume of a cylinder, talking about volume first, just what is volume? So volume is the measure of what we can put inside something, right? So here I've got this 2-liter bottle, and within it I put some water. I colored it blue so you can see a little bit better. But when we're talking about volume, we're measuring how much water I could put in this, or how much air is in this, what kind of space is on the inside of a three-dimensional figure. So just to say that, right, let's just get a definition for volume here. And what we're talking about then is the capacity or space inside a 3D shape. Whoa, a Chappé. Right, how much room is there inside something? When we do problems about volume 2, we're going to talk about it, and we're going to label it in whatever units we're using, and then cubed, and that's like centimeters cubed is an example of that. And the reason we do that is because since we're working with a three-dimensional figure, if you go back to area where we're talking about two-dimensional figures, we're multiplying a base and a height. In three-dimensional figures, we're multiplying three different dimensions. So that would be then something like centimeters times centimeters times centimeters, which in the end will give us centimeters cubed. Now we usually just do the numbers. That's not a big deal. But understanding that those units, whatever units are attached to those numbers, those are multiplied as well. And that's why we end up with centimeters cubed at the end. Let's get a definition for a cylinder. Let me get it. Oh, I got a cylinder right here. Super. This is a cylinder. You can see it is two circular bases. Those bases are congruent, which means that they are measured as the same shape. Then those are separated by a distance here. Because these bases are parallel, they'll never meet if they were extended off into infinity. So that definition then of a cylinder, right? We've got a three-dimensional figure, two parallel circular bases, of course separated by a distance. And then just so we have an example of this, for example, now what I showed you was a shipping tube. Right, I've got a shipping tube here for posters, but you could just as well think of, the classic one that I think of is when you're wrapping gifts for somebody, and you run out of wrapping paper, right? And you end up with that tube that you get at the end, or the end of the tube that you have in a paper towel roll. That's what a cylinder is. So we're going to be checking the volume of cylinders right now. Okay, let's do a couple of these, and we're going to draw them. So it's, no judging here. This is a judgment-free zone. So if I'm going to draw a cylinder, what I want to start with is an oval, okay? And then I'm going to make the same oval just above it. So about like that. And it isn't great, but it's going to work for us. So then I'm going to connect my outer sides here. It's a little Bob Ross moment for us. Then I need to label it. So I need a height here of 21 inches. And then let's put a dot here at the center of our circle and draw it out and say our radius is 13 inches. There's our cylinder. It's not perfect, but it's going to work for us. All right, so we need a formula. This is the best thing about this. So you get to use a formula with this, and the formula is pretty simple. What it is it's the area of the circle times the height of the shape. So just taking that area, we're just multiplying how many of those circles are in there based on the distance they are from each other, or the height of that shape. Now remember that when we talk about this word height, we're not talking about how tall something is. We're talking about how far each of these shapes is. How far is this oval from that oval, or that circle from that circle? So to do this, here's the formula. The formula is pi times radius squared. That's the area of the circle. And then we're going to multiply that by the height, which is the distance between the two bases. Now for doing this, we're going to use our calculator. So as I put this in the calculator, it's going to look like this. Pi times, so pi times my radius, 13, then the squared button, 13 squared, times the distance between the bases. All right. Then I hit enter. And now I get a pretty big number. And that's totally fine. We expect a big number. These are not small numbers. So when we look at this, though, we want to go to the nearest tenth. And what that's going to give us is 11149.51. We're going to round, right? So I put the hundredths place there so we could look at it. It's less than 5, which means we're going to keep the tenths place as 5. So I'm going to erase that. If we go back and look at this, our units were inches, which means we're going to do inches to the third. Now, I always like to write the number first and then put the comma in afterwards. So I know where the decimal is. 11,149.5 inches cubed, right? Not squared, cubed. Let's do one more, but this time we're going to do it a little bit different. This one's going to be in terms of pi. So in this, we almost have something that is slightly, make this a little different this time. So we get those the same. I just drew it on the side, that's all, not a big deal. This time we're going to solve this in terms of pi. So let me write this here, in terms of pi. In this then, we're going to have pi in our answer, the actual symbol in our answer. And what that does is it gives a really easy comparison with things, and then there's no mistake on what value somebody might have used for pi in terms of doing a calculation. So in this, I've got my cylinder here. I'm going to have a distance between the bases or a height of 21 meters. Let's make it, it's a giant, it's huge. It's like a smokestack. And then a radius here of 15 meters. And then when we do the calculation, we're going to use the same formula again. And that is pi times 15 squared times 28. Now in this case, when I put this in my calculator, let me switch up my colors here. When I put this in my calculator, what I'm going to do is, this is going to be in my answer. So I'm not going to put it in the calculator. The only part that I'm going to put in the calculator is going to be this. Okay? So when I do this, get up my handy dandy here. 15 squared times 28. And there's my value. So let me write that in blue. This is a bad blue. And I get 6,300. We have to switch. The blue's just not cutting it. We got to go to the black. Red down. Now I dropped the red. 6,300. And then here comes pi. So pi is just along for the ride. And we're going to have pi there. And then we put our units in. So then our units are meters cubed. Meters cubed. And that's what it looks like when we solve in terms of pi. So in terms of pi is, we want pi to still be in the answer, but only as the symbol, not in the multiplication. The only thing we're multiplying is anything that isn't pi. All right, if you have questions, of course, you can ask me. Good luck.